will record this session, and you'll have a file probably by tomorrow morning of this session that you can review, and it'll just be a recording of the audio plus whatever I'm writing on my screen.
Okay, cool.
Okay. What would you like to cover today, Jackson?
I have this worksheet on, I'm not really sure what it's called. It's like finding X in a circle, and do you want me to send you a picture of it?
That's probably the easiest thing to do. If it's difficult to verbalize, send it to this email address that I'm writing on my screen.
Okay.
This is the email address that comes directly to me.
Okay, I'll email you a picture of it.
Okay.
I got some of it done. I didn't get the bottom half.
Okay. Let me open up my emails. Have you sent it yet?
No. Could you put back up the email?
Yeah. It's David Cowan 1949 at gmail.com.
Okay, I just sent it.
Okay. Incidentally, that GoToMeeting rectangle that you see can be minimized if you click on the white arrow in the little orange box. That acts as a toggle switch and opens it and closes it.
Okay.
It makes a little more room on your desktop if you have it closed. There it is. Circles and tangents and secant lines and all of that good stuff.
Yeah.
All right, where would you like to start? You want to look at some of the stuff you've done? Just have me check to make sure it's okay?
Yeah, sure.
Okay. So what's the principle at play in number 1?
You have to do 23 times x equals to 23 times 15.
Okay, because we have two intersecting chords inside of a circle. And this one would be 6x equals 12.
Yeah.
Looks like you understand that pretty good. All right. And number 4, just looks like it's the same thing. X times 12 equals... Now, the way you've written x plus 5 times 6, let's talk about it.
Okay.
Let me put up my screen here. Should be like this. In other words, you have to multiply the 6 times the x plus 5 quantity. It's not just, if you write it like this, that's different actually. That's x plus 30. Whereas this is 6x plus 30. So those parentheses make a lot of difference. You need them. And the general guideline with parentheses is it's better to overuse them than to underuse them. You can't really get in trouble by overusing them. You can get in trouble by underusing them. All right, I won't even check the solution. I'm assuming you can do the arithmetic correct. So this is x plus 10, let's see. I think this x plus 10, it's hard to tell. Does it go with this part of the line?
The x plus 1, yeah.
Okay, I think, let's see, this writing right here, does this go with problem 5?
Yeah.
So we got x times, that is probably x plus 13.
Yeah.
So it should be x times the quantity x plus 13, not x plus 3, equals x plus 1, and I can only presume that that's x plus 10 there. Can you see my little hand that I'm moving back and forth? Okay, cool. Hold on one second. It's prompting me to change my screen colors. Okay. So the equation you would want is not the one you've got written there. The equation you would want would be if we take x times x plus 13 in parentheses, that's equal to x plus 1 times x plus 10. Okay?
Yeah.
Now let's do the math here. Let's make sure you can get through the algebra part. So tell me what the next line would be.
It'd be 2x plus 13 equals...
Okay, stop right there. X times x is x squared.
Oh, yeah.
X times 13 is 13x. Okay. And then on the right side of the equation, how do we multiply this binomial by this binomial?
You have to FOIL.
Okay, give me each term.
Okay, so it's x squared plus 10x plus x plus 10.
Okay, now what?
The x squares cancel out.
Okay.
And the x's combined, so it's 11x plus 10 equals 13. X. 13.
Okay, now what?
Subtract 11x from both sides.
Okay, so tell me the next line.
And then it's 2x equals 10, and you just divide both by 2 and get 5.
Okay. Good. It's like you know your algebra pretty good. That's good.
Yeah.
Because a lot of times by the end of geometry class, it's real easy to forget the algebra that one has learned. This one up here, what's the equation on number 6?
X times x minus 6.
Okay.
X times x minus 6 equals to x minus 10 times x.
Times x plus 12.
Oh, yeah.
In other words, because they've used a printer for this, it's not easy for them to label easily. In other words, is this line x minus 6 or is that x plus 12? Well, as long as we see that there are only 4 segments to be labeled, this top little segment here has to be x minus 6. This one has to be x plus 12. This one has to be x. And this tiny little one that the arrow points to is x minus 10. As long as you've got x minus 10 times x minus 6 equals x minus 10 times x plus 12 equals x times x minus 6.
Yeah.
All right, these are a little different. When you have a secant lines that intersect outside of a circle, it's not 3 times x equals 2 times 10. It's not the same as with chords. It's 3 times the entire length of that thing, which is 3 plus x, equals 2 times 2 plus 10. In other words, the
Okay.
equation is going to be 3 times 3 plus x, the entire length of that top secant line. And that has to be equal to the extended part, 2, times the entire length of that secant line, which is 12.
Okay.
And now it becomes easy. So number 8, same thing. 2 secant lines that intersect outside of the circle. What's the equation that I want to write?
You want 5 times 8 equals 4 times 4x.
Times 4 plus x.
4 plus x.
In other words, we want 4 times the entire length of this line, which is x plus 4.
Yeah.
Okay, and this is also pretty easy to solve. I don't think you're going to have any problem with that. What's the equation for number 9?
6 times 10 equals 5 times 5 plus x.
Good. Find RT and TV. Okay. What equation? Hold on. Let me bring it to the, okay. What equation can I write?
You can do 8 times x plus 3. Wait, 8 times x plus 3 plus 8, right?
Yep.
And that's equal to 10 times x minus 3 plus 10.
Go ahead and let's finish this out. Distribute.
Okay. 8x plus 24 plus 64 equals 10x minus 30 plus 100.
Combine.
And then on the left it's 8x plus 88 equals to 10x plus 70.
Keep going.
You subtract 8x from each side, and it's 88 equals 10x or 2x plus 70.
Okay. And then.
And then you subtract 70 from each side.
Okay.
And then you get 18 equals 2x, and then you divide them both by 2 and get 9.
Good. All right. There must be an 11 here somewhere. How come I don't see an 11?
I don't really know.
Go from 10. It looks like there should have been an 11 here and a 12 here, but somebody erased them or something.
Yeah, my teacher might have done that.
Okay, this is slightly different, although you don't really need to treat this any different. This is the same situation. Even though one of the lines is a tangent line and one of them is a secant line, I can look at this as exactly the same thing. In other words, I can say 5 times 5 plus x equals the extended part, 10, and times the entire length of that line, which is 10. So if they give you a separate equation that says this times the whole thing equals this squared, but you don't really have to remember that as a separate equation. You can treat it like this tangent line as a secant line. You're multiplying the extended part times the entire part.
Okay.
Okay? And Yeah, that's pretty trivial to solve also. What happens when we get an x squared? Well, let's see if we get one first. Okay, so here we go. Coming right up. Give me the equation here.
X squared equals 9 times 7, or 9 times 16.
Okay, solve that.
Okay, well, you get 9 times 16 is 144.
Okay.
And 144 square, or the square root of 144 is 12.
Okay. Actually, as long as we're talking about this, let's talk about it. Really, when you solve an algebraic equation by taking the square root of both sides, you always get plus or minus 12.
Oh, yeah.
But in geometry, since you're generally trying to solve for dimensions, there's no such thing as a negative dimension. So you would throw out the negative solution and only keep the positive solution. However, if this thing was something like x plus 13, then x could actually be minus 12.
Yeah.
If that really did say x plus 13 and we solved for x and we got plus or minus 12, both solutions would work and you would have to take both of them. But the most important thing to remember is that when you're solving algebraic equations and you take the square root of both sides, always begin your answer with plus or minus. I have tons of students that come out of geometry and they've just spent a whole year dealing with nothing but the positive solutions, and so they kind of forget that it's always plus or minus. And that's the single biggest mistake that if I took all 200 students that I've ever had and said, what's the single biggest mistake they make? That's it. Leaving out the plus or minus. Now, it's not so important with geometry, but you're going to be in Algebra 2 next year, so never too soon to get a good head start on good practices.
Yeah.
So what equation can I write from 15?
15 times 15 equals 9 times 9 plus 4x.
Yeah. And when you're verbalizing those, it's probably a good thing to say 9 times the quantity 9 plus 4x. And when you add that, it implies that there's parentheses around the 9 plus 4x. Because you don't want to do this. That's different.
Yeah, that would be good.
In other words, if I just said 9 times 9 plus 4x, what I'm really saying is that. But if I say 9 times the quantity 9 plus 4x, I'm saying this up here. Okay? Minor thing, but as long as 16's missing also, I think, maybe. No.
No, it's
yeah, it's there. I just didn't see it. I had my screen messed up. Okay. So, what equation here? Find PQ. Okay.
You can do x squared equals
what's x?
PQ.
Okay. Let's do PQ squared.
Okay.
Equals what?
Equals 12 plus...
12 times?
Oh yeah, 12 times. Yeah, 12 times 27.
Okay, and what's that number?
It's...
Do you have a little calculator in front of you?
Yeah. 324.
Okay. And what's next?
X is 18.
Okay. Again, it's plus or minus, but we throw out the minus.
Oh, yeah.
Okay. Boy, they believe in Just drilling the same thing over and over, huh?
Yeah.
That's good, actually. I actually like that a lot. Usually you only get one or two of a type problem, and then they go to a different type problem. And the thing that really plants it in your brain is when you just do a bunch of them.
Yeah.
What's the equation here?
24 plus, or times the quantity of 24 plus x equals 36 times 36.
Yeah, 36 squared.
Okay.
That's fine to just leave it like that. In other words, if I was testing your arithmetic, we'd want to take these to the end, make sure you come up with the right x, but I'm confident that you know how to do the arithmetic once we get it set up.
Yeah.
Okay. What else?
I have some bookwork, but
Okay.
other than
Let's back on that.
that much.
Is it bookwork that you can verbalize, or is it bookwork that we need to look at a graph?
It's a lot more of these circle problems.
Okay.
So should I email you a picture?
Yeah, go ahead.
Okay.
Is your geometry book by Larson, Boswell, and Stiff?
Yeah, and Canold or something.
Yeah, I think I have the same book. What chapter? Is it chapter 10 on circles?
Yeah, it's 10.
Where in chapter 10? I've got a different edition, but you may not have to send it to me. I may just be able to look it up.
Okay, the page is 683.
Let me go to 683. My 683 doesn't have. My 683 is 11.4. What's your subchapter?
10.5.
10.5. Let me go to 10.5. Is it at the back of 10.5?
What do you mean?
Are these problems, are they at the exercises at the end of 10.5?
Yeah.
Okay, I'm looking at a bunch of them. Before you go to sending it, under practice and applications.
Practice and application.
They may call it something different, but I have one here that's x times 9 equals 12 times 15.
I don't
You
see
don't
that
have that
anywhere on
one?
here.
Go ahead and send me yours.
Okay.
Sometimes they change the exercises up. A lot of times I've noticed that they don't. That might be on different pages, but they're the same problems when you go from one edition to another. So even though I might have the same book, I may not have the same problems.
And it's David Cohen 1949 at gmail.com.
Yeah. Here, I think yeah, I still have it right there.
Okay, perfect.
Actually, what kind of phone do you have? Is it a Apple or a
Galaxy.
Galaxy? Okay, so it's an Android. Should be when you go to send that picture, when you type in the first two letters, DA, it should show you a list, and I probably will be right there at the top. Because you just...
Yeah.
So you don't have to retype the whole thing.
Yeah, I just sent it.
Okay. You go to chat field, don't you, Jackson?
Yeah. Yeah, I do.
Okay. Yeah, I've got quite a few chat field students, and they're all in the same part of geometry.
Oh, really?
Circles,
Oh.
There it is.
And I only have 3 through 5 and 7 through 12 on this.
Okay. What's the measurement of arc AB?
65 times 2, right?
Yeah. In other words, the angle 65 degrees is 1/2 the measurement of that arc. So the measurement of that arc must be 130.
Mm-hmm.
Likewise, the measurement of this arc, or, you know, from A to B that way, which we know is going to be 295, but it's also twice this angle, which is 115. Did I say 295? What's going on here? Let's see. Oh, no, this was 130, sorry. So this has to be 230, which is twice 115. So that's right. Yeah. All right, number 4. What's the measurement of DEF?
234.
Okay. And number 5. What's the measurement of angle 1?
130.
These are tough, aren't they? It's amazing how many of these relationships have half in equations. So, what's angle X?
Is it 145 plus 85 divided by 2?
It is. Again, half. Here, how about number 8? Excuse me, let me get my thing here and I'll drop it down so I can write. How are we going to do number 8?
You could do 180 minus 122.5.
Okay, that gives you that angle there.
Yeah, and then you can set it up so
that's 57.5 degrees.
Yeah.
What is that equal
and then
to?
X plus 45 divided by 2.
Okay. Quantity, X plus 45 divided by 2. Let's solve this equation.
Okay, so you multiply the whole thing by 2 and then 57.5 by 2. And then you have X plus 45 equals 115. And you just subtract 45 from 115 and get 70.
Okay. The one thing when you have a problem like this that you don't want to do is distribute that 1/2. Some people are inclined to do this as a first step, which is X over 2 plus 45 over 2.
And
then the thing just gets more complicated than it needs to be. The simplest way to solve an equation is to get rid of the denominators as your first step. If you can get rid of all denominators in one or more steps, it turns the thing into a much simpler equation to solve.
Okay.
All right. And the key with all of these is just to be able to write an equation. Looks like we might have missed part of this. What equation can I write on number 9? You're going to have to fill in the rest. There's something else beyond that 2x. The only reason I know is because there's a left paren there.
There's a what?
There's a left parentheses in front of the 2x. So that probably means there's something else after the 2x.
Okay, so would it be 2x minus 30 plus, or the quantity of 2x minus
Is that what
30?
that's? In other words, you can see I can't see that number. So that
Oh,
says
really?
2x minus 30?
Yeah.
Okay. So it's 2x minus 30
Plus 30 divided by 2 equals
one of these angles, either that one or that one.
Yeah.
Okay. Well, that's x. In other words, if I do this math, the 30s cancel, and I got 2x divided by 2. So that angle is x,
Uh-huh.
and this angle is x. So what is x?
Could you repeat that?
Yeah. In other words, what we calculate when we use that formula for intersecting chords is that this angle is x.
Yeah.
They want to know what this angle is. In other words, this is the first thing we can calculate. We don't have to call it x. We can just say that that angle, well, we do have to call it x because it's half of 2x minus 30 plus 30. So this angle is x. Well, they've also labeled this angle as x. Since they both are the same, what are they? How big?
Yeah. Since they both...
They have to both be 90 degrees.
Oh, okay.
Okay? Because we know that x plus x equals 180. So x is 90.
Oh, okay.
Okay? They've kind of confused the issue here by labeling this angle as x and labeling x also up there. They made it a little more confusing than it really needs to be.
Yeah, no kidding.
But geometry is famous for that. Yeah, at least you're not doing proofs anymore, right?
Yeah, I hated those.
Everybody
Oh my
does.
god.
I can't believe they start off geometry curriculums with proofs.
Yeah.
Totally intimidating. Everybody hates it. So, how am I going to do 10? What is x going to be equal to?
X is... Let me get my worksheet. X is the degree times...
It's the difference of the two arcs that get created.
Oh, okay.
We get one arc that's 247 degrees. We get another arc going this way. How big is that arc there?
It's 247 divided by 2.
Well, hold on. No, not yet. First of all, we got to calculate what this arc length is right here. It's 360 minus 247.
Oh, yeah.
So that arc length is 113.
Okay.
So x is the difference in the two arc lengths. So 247 minus 113 divided by 2. Like everything else with circles. One half is huge in there. So let's see if this one makes sense. It's always a good idea to check these and see if they make sense. So what do we have? We have 134 divided by 2. What is that? 67?
Yeah.
Does that look like a 67-degree angle? Yeah.
Yeah.
Yeah, I mean, as much as we can approximate it by visual. In other words, we didn't want to come up with an answer like 110. We'd have come up with some angle bigger than 90. Well, we can kind of look at that and see that it's not bigger than 90. Now, they don't always draw these to scale, so you can't always use that. You wouldn't want to use that if you were taking the SAT test or the ACT test because they do not draw their pictures to scale. But in general, it's a good idea. In other words, maybe we got our formula wrong. Maybe it's 247 plus 113. You know, well, if we do that, we realize that we get some huge angle, and that's not that angle, we can tell. So a lot of times just being able to eyeball it and make sure that you're in the ballpark is helpful, just to tell you whether you've got the formula right or not. Because there's a lot of formulas they're asking you to memorize here. And, okay, number 11. 29 degrees is equal to what?
29 equals 114 minus x divided by 2.
Quantity or just?
Quantity.
Okay. Solve this.
Okay.
What's the next step in solving?
Oh.
I should have said solve it out loud so I can write down your steps.
You multiply both sides by 2.
Okay, so 58 equals 114 minus x.
And then you subtract 114 from both sides.
Okay, we can do it that way. The reason I wanted to solve this was to talk about this. In algebra, you're always going to make fewer mistakes the fewer minus signs you deal with. Agreed?
Mm-hmm. Yeah.
Okay. Well, if I subtract 114 from both sides, then I'm going to have a negative sign on the left. I'm going to have my negative x on the right. Mm-hmm. Let me suggest there's a better way to do it, which is to move the negative x to the left side, move the 58 to the right side. Now I can subtract 58 from 114, and I get 56, and I got nothing but positive numbers. It's going to give you the same answer if you did it the way you suggested doing it. It's just that we're going to end up with negative 56 equals negative x. Now we got to divide both sides by negative 1. So it's no fewer steps. It's the same number of steps, but just by avoiding the negative signs, I'm going to have a greater likelihood that I don't make an arithmetic error.
Yeah.
Okay, number 12. I'm missing some information on this arc length right there. What does that say?
It says 3x minus 2.
Okay, so 34 degrees equals what?
34 degrees equals x plus 6, the quantity of x plus 6 plus the quantity of 3x minus 2 divided by 2.
It's the difference of those two, not the sum.
Okay.
Okay, so it's, what was this, 3x minus 2?
Yeah.
So it's 3x minus 2 in parentheses. Let's just use it whether we need it or not. Minus, in parentheses, x plus 6. And this second set of parentheses we definitely need. If I don't use the second set of parentheses, then I'm going to get the wrong sign on this 6. Okay? So this is the way I start my equation. Now my goal is to remove all of the parentheses. That's the next step. Well,
wouldn't you divide it by 2?
Oh, yes, excuse me. Sorry. Yes, divided by 2. So the first step is to multiply by 2. So that turns that to 68. And now the next step is to remove the parentheses. Well, I can remove the first set of parentheses without doing anything. I didn't need those in the first place. I used them because they were clarifying. It helped us understand what we were doing. We were taking this arc and subtracting this arc.
Yeah.
Okay? But to remove the second set of parentheses, what do I get?
You have to apply the negative to both of them, so it'd be negative 3x plus 2.
Hold on, it's negative x minus 6.
Oh, yeah, wrong. I did the wrong parentheses.
It's okay. And then How does that simplify?
It simplifies to 68 equals 2x minus 8.
All right. I trust you know how to do the rest of it.
Yeah.
Okay. 13.
And then that's all I had.
Oh, you don't have to do 13?
No.
Okay.
Thank you.
Yeah, nothing else?
Nope, that was it.
All right. Let's see. Before you sign off, let me think. Can I get an email address from, hold on,
Yeah.
or your mom or dad, whoever I would need to send an invoice to?
Yeah, I'll give you my mom.
Okay, Kelly's? Yeah, what's her email address?
Nash Appraisal Group.
Is that with 2 P's or 1 P?
2 P's.
Okay, at
MSN.com.
okay. And she apparently, let's see, you signed up online, didn't you? Or did I make this appointment with you when we met the first time?
You made this appointment when we met.
Okay, do you want to schedule another one while we're talking, or?
Yeah.
Let's look at my schedule.
Okay.
Hold on. Okay. You can actually do this online if you want, but a lot of times it's easier if you do it with me. So here's what my schedule looks like next week. Do you want the same time on Thursday at 3:30?
Yeah.
You want it just till the end of the year? You want it regularly?
Yeah, sure.
I'll go ahead and lock it up for you, and you'll have it every Thursday at 3:30 online.
Okay, thank you.
Okay? All right, Jackson. I will talk to you next Thursday.
Okay, see you.
All right, bye-bye.